Hey YouTube, we got another physics example, and this one gets more into forces and Newton's laws. And this example is a classic example of one of the basic physics problems that I know that we go over a lot in my physics classes. We have two masses. One is on a frictionless table connected to a wire that runs over a pulley which is frictionless as well, and is connected to some mass 2 that's just hanging there over the pulley. So what we want to find is, what is the acceleration of the mass of M2? Well, the first part was what we do is the number one thing that we always do is draw free body diagrams for each one. So I'll do that up here actually. So on M1 we got the normal force and the gravitational force, which is mg, and then we got the tension of that rope. And then for M2, so I'm just going to label this M1. So then for M2, we got the tension force, and then we got the gravitational force on that one. So we should label our axes as well. Y, X. We're just finding what's positive, what's negative. So then we're going to sum all the X forces and all the forces in the X direction and all the forces in the Y direction on each one of these diagrams. So in the Y direction, we have the normal force minus the gravitational force. And well, this block does not have any, isn't moving in the Y direction at all. It's just going across this table, horizontally. So it's just going like this. It doesn't have any Y, and doesn't have any component of Y. So then this is just going to equal, your normal force equals your gravitational force. And this is because your first mass does not have any Y component. So now for the X direction of these forces, it's just your tension equals your negative M1A. So that's for your mass 1. Now for your mass 2, it's your tension minus your gravitational force, because your tension is in the positive Y direction. Your gravitational force is in the negative Y direction, so that's why you put minus mg. And we know it's accelerating down, so that means your force is going to be in the negative direction, so it's negative m2a. So then we can, well, we said over here tension is equal to negative m1a. So then we could say, we could plug in the tension over here. So it's negative m1a minus mg. Hold on a second, let's just cross that out. So what I'm going to do is I'm going to switch these two. So this is M2. So this is tension plus M2A equals M2G. So I'm going to plug in the tension force over here now. So it's going to be negative M1A plus M2A. I'm sorry, but that negative is actually a positive because it's accelerating in the positive X direction instead of the negative X direction. This equals M2G. This is positive M1A and this is positive M1A now. And it's positive because it's accelerating in the positive X direction, because that's why I defined our axis is what's positive and what's negative. So we know that our positive Y is up and our negative Y is down, and our positive X is to the right and our negative X is to the left. So then they want the value of acceleration, right? So then we're going to go A times M1 plus M2 equals m2g. I'll write this real big over here. That means A equals m2g all over m1 plus m2. Well, this equals, well, we said that in this problem, we said that m1 equals 0.5 kilograms. And we'll say m2 equals 1.5 kilograms. And then we'll say, well, we know our acceleration is 9.81 meters per second squared. So then we're just going to go 1.5 kilograms multiplied by 9.81 meters per second squared all over 0.5 kilograms plus 1.5 kilograms. Well, all these kilograms are going to cancel out. And that's going to leave us with our acceleration, which I can solve for you real quick. Our acceleration is going to be 7.35 meters per second squared. And that's our first example of a classic. We have two masses connected by a pulley, and we want to know the acceleration of these masses. So what we did is we defined our coordinate axis of what's positive and what's negative. We drew our free body diagrams, so we did the normal force minus the gravitational force based on what we put as positive and negative on our axis. And then we said the tension force equals m1a in our x components of our forces. And then we drew the free body diagram for m2, which is our tension force minus our gravitational force, which equals negative m2a because our acceleration, because our force is, our F net is in the negative x direction, or negative y direction, sorry. So then we just set up an equation, plugged in our tension force, and solved for A, and it all came out to be 7.